Good morning, students. Today we will begin with a new chapter, that is your unit 5. That is your problem solving methodology. Problem solving methodology. Okay, so what happens here in the problem solving methodology? That is the process. It is the process where the problem will be solved in various ways to reach the solution. The problem may be get through certain mathematical expressions, or it also uses some logical concept to get the answer. Okay, so in the problem solving methodology, you will learn how to solve the problem. So before going to learn about any programming languages, that is your C programming or C++, Python, Java, then that is the higher level programming languages are there. And before that, you must learn how to put the logic and get the answer. So this is nothing but here you will study about the algorithm, the flow chart, pseudocode. So this algorithm is not a program, this is the logic, and these are the pseudocode which you will be implemented in your programming language. So here, the problem solving methodology, the first thing is that the main point is the problem. So there are various problems, whether you are doing any calculations, whether you are doing some logical operations. So how do you solve this problem? So for that reason, first thing you have to do that you must understand the problem. The first step is you must have to understand the problem. The second step, that is you must have to analyze the problem. Okay, then you must have to design the problem. There are various DFT, data flow diagrams are there. Design the problem. Then you have to code the problem. Means code the problems means you can use many various programming languages to sort out this problem or solve the problem. So when after getting the understanding of the problem, after analyze the problem, after designing the problem, you have to code it. So it's your choice that whether you are doing the solution, find out the solution using your C programming or your C++ or Python or Java. Okay, so this is the problem solving methodology. The problem solving methodology, the first thing you will learn, that is your algorithm. So in the problem solving methodology, the first thing that you will learn, that is your what? Algorithm. So here you will learn that the first thing, algorithm. Okay. So algorithm is nothing but the step-by-step procedure. And in this step-by-step procedure, you have to put certain logic to get the answer. Okay. So this is nothing but the step-by-step procedure. Okay. So this is nothing but the step-by-step procedure. Okay. So here what happens that you have to write certain steps. It doesn't mean you have to write a very long steps, 2 to 3 pages steps. So before going to learn about this algorithm, you must have to know what should be there so that your algorithm will be the better one. What are the features of an algorithm? What are points that you have to remember when you are writing any algorithm. Okay, so the first thing that whenever you are writing any algorithm, the characteristics or you say that the features that the first thing that of any algorithm that it should be finite one. It should be finite. It should be precise. Okay. It should be some meaningful statement will be there. Okay. So here the finite, what does it mean? Whenever we are saying that the finite. Okay, finite one means suppose I'm saying that you had to count or you have to add the numbers up to the infinite one. So can you say that what is the value of infinite? You can't say. So infinite means what? We don't know the value of infinite. So this will be the linear process, never ending process. So whenever you are writing any algorithm, your algorithm should be the finite one. Means there are certain steps, after certain steps or after some time it will be end. It must have some end. 3 to 4 steps or 4 to 5 steps. So the thing is that there is no any rules that someone writing the algorithm using 4 steps, someone writing the algorithm using 5 steps or 6 steps. Okay, so that matters. But it doesn't mean that you have to calculate the things lengthier one, that is the never ending process. So it must have the finite one. The next thing that is the precise one. So each and every step should be precise. That I will give you some examples that each and every step should be the precisely written. Means that it only depends upon that the sequence. It has to follow certain sequence. Okay, it has to follow certain sequence. There is no ambiguity between this. Other thing that is ambiguity. Ambiguity. So there is unambiguous strategy, or we can say that is unambiguous. You say unambiguous. Okay, unambiguous. Okay, unambiguous, which means that you know that a coin has 2 parts, one head and tail. That you know. That is the simple thing. The coin has 2 parts. That is, one is the head and the another is tail. So there is no ambiguity. Okay, so that should be unambiguous. Means each and every step should not have any confusion. Okay, so then this is the precise one. This is the unambiguity. The other thing is that is your uniqueness. Uniqueness means each step is different from each other, but the next step is only depend on its previous step. Suppose there are 3 to 4 steps, so it only depends on its previous steps. So each step should be the precise one. Each step should be the algorithm should be the finite one. Unambiguous and uniqueness means this step never repeated in the second step. Suppose this is A plus B, then that is not repeated on the second step, that is A plus B. Okay, so only the thing is that only the last step will only depend on its previous step. So this is also depend on this previous step. This is only depend on this previous step. Okay, so that means that is the uniqueness. And effectiveness. Effectiveness means we have to write the algorithm in such a way that the basic things will be only present in that algorithm, not other things. Okay, and that should have completed within some finite amount of time. Like I said that if it is the infinite one, infinite number of additions, infinite number of multiplications, then we cannot get the answer. That is the never-ending process. Okay, so other one, that is your effectiveness. Okay. So next thing, that is the control structures in algorithm. The first one is your sequence. Sequence means whenever, just remember and recall mathematics. Whenever you are doing some calculations, then you have to write step by step. Okay, you are calculating step by step, then a plus b, b plus c, whatever the answer will be. Then you have calculating in step by step manner. Then here also will follow some sequence. Suppose I want to say that whether a number is even or odd. The first thing is that even or odd, the number which is divisible by 2, then that is the even number, and if it's not divisible by 2, then that is the odd number. So the first thing is that divisible by 2. So how to write these things in this logic or in this algorithm? So the thing is that if any number, suppose I take a number, that is your any number which is divisible by, this is your modulo operator. If the number is divisible by 2 and the remainder is 0, then that is your even number. Okay. And next thing, that if it is not divisible by 2 and the remainder is अगर 0 नहीं हो रहा है, then that is the odd number. Okay, so just write these things in a sequence. So after this is one logic. So we can give such examples in your decision making statements. Okay, so first thing that we have to follow some sequence. So simple statement, just write. Suppose I want to add two numbers. So the first one, step 1. Input a number. Suppose this is A. Step 2. Input second number. Suppose write here first number. This is the second number. Input a second number. That is B. Now step 3. That is set sum equal to A plus B. Okay. Now I want to see the result. Then that is step 4. Print sum. Then step 5. After writing any algorithm, the last one is your step 5. That is your end. You have to write this. You must write this. Okay. You can write step 1 as start. In somewhere you can find that the first one is a start. Okay. So what happens here? Suppose there is two numbers, that is 2 and 1. Okay, 2 and 1. So the addition will be your 3. The first thing what says? The first number, that is 2. The second number what? 1. Then set sum equal to A plus B, which means yeah, 2 plus 1. What will the result? That will be your 3. So the result will be stored in your sum. So now I want to print sum. When I will print sum, then it will show you the result, that is 3. So this is the logic. So this logic will be after putting this logic, you are able to draw the flowchart, and you will also implement this thing in your pseudocode. You can write by using this logic in your pseudocode, and and you are applying this pseudocode. Pseudocode is nothing but simple English language, simple English form that is written in a simple English form, and you can implement this in your program. Okay, so the last one is here. So see here, this is the 5 step. You can write this in 2 steps, 4 steps only. You can write it. Okay, which means that this is step 1, this is step 2. Suppose instead of writing this in step 2, I will write suppose input 2 numbers. Okay, I am writing here input 2 numbers. Input 2 numbers A and B. Now I write this as step 2. Okay, step 2. Suppose here this will be suppose step 2 and this will be suppose step 3. Okay, this will be suppose step 3 and your this one, this is step 4. So I can write this in 4 steps also. Okay, so it matters how many steps you are using. The lesser steps you use and the you must have to put the better logic, and it doesn't mean that if you write the algorithm in 3 to 4 pages, then you will secure the more mark. The thing is that why we should which algorithm will be the good one if the basic things will be there. Next thing, it should be completed in finite amount of time. The next thing, that how many steps you are included to sort out that problem and find out the solutions. Okay, and the another thing is that how to write this algorithm. Is your algorithm is correct or not? Basic logic you are applied or not? That also matters. Okay, so thing is that just always keep in mind that within some steps, few steps, you can write the algorithm. Okay, so just basic steps you have to include there. Okay, so this is your sequence. The next thing is the decision. Okay, decision means if you have 2 choices, then which will you choose? Either you choose the first one or the second one. So that is the option. Whenever we have some options, then it's up to us, the decision will be taken by us and find out which is appropriate for us. Okay, so the thing is that whether in this control structures which is used in your algorithm, decision means, like I have already given you some examples, that is if your age is 18 plus, then you will eligible to give vote, or you are participating in your election. Okay, and if you are not, then you can't give the vote. Okay, so here the thing is that suppose there are many decision making statements are there. If you are using if else, then nested if else. Okay, this first simple example, that if here you are putting some condition, if the condition is true, then you have to, your statement, whatever statement you write here, that will be executed. Okay. Then whatever statement you are writing here, that will be executed. Else statement will be executed. Means here I am not using else statement. It's only the if statement, if condition. If there is else, then you are writing here else. Else statement 2 will be executed. Okay. Means if suppose just give the example, I am giving you the example of suppose that n modulo 2 equal to 0. Okay, means whether the number is even or odd. a number or enter a number. Suppose this is n. Okay. Step 2. If n modulo 2 equal to 0, if the remainder is 0, like I am doing 4 divided by 2, then 2 2s are 4, then remainder is 0, means the remainder is 0, means this 4 is the even number. 6 like that, but whenever I am dividing 3 by 2, then the remainder is not 0, that will be must 2 ones are 2, that is 1, or some point some values are there. Okay, so here the thing is that when n modulo 2 equal to 0, so whenever you are writing the program, certain program, then you have to put the logic. Then in the output screen, you will enter the number, which number will be there, whether it's 4, 5, 6, that will be tested in the output screen. Okay, so here if n modulo 2 equal to 0, if the remainder is 0, then what? The statement 1, print even. Suppose writing print even. Okay. If I am using else statement, then I am writing here else print or. Okay. Then step 3. You must have to end this. Okay. So this means this is what? This is the decision making step. Decision. You are taking here the decision whether the number is odd or even. Okay. Then the another thing is your iteration. Just remove this. Iteration. So whenever I say that iterations, if I say that just print hello 5 times. Print hello 5 times. Okay. If I am saying that print hello 5 times, then how will you print? You have to write hello, hello, this one 5 times. Hello, hello, and again hello. This is 5 times. If I am telling you that, if I say that just write it 1000 times, then it will be difficult for you to write write this hello word 1000 of times. That means that this is wastage of time also and wastage of paper. If you are writing these things in your memory system, then wastage of memory also. Okay, so what can I do so that I will get the better result within stipulated time also, and time will be secure, and my memory will be also, I will use the less memory. Okay, so here I am giving you some examples, like I want to print hello 5 times. Okay, so for that reason I am writing here, first thing I have to initialize the things. How many times I want to see this hello? Suppose I want to see this hello in 5 times or 1000 times. Okay, so no need to write these things again and again and consume the memory. Okay, here, if I want to print these things, then okay, then how to write this? For step 1, I have to initialize this. Okay, I have to initialize. Then first thing, initialize I equal to, suppose from where you want to start, 0 or from 1. Suppose 1, from 1. Okay, then this is 1. Then what I will write from what is the limit? So I will set the limit and equal to your 5. Okay, and equal to your 5. Okay, so if I want to print hello 5 times, then how to write it? I will count from this 1 to 5. Okay, then step 2. This is the step 1. This is step. In step 2, what I will write? Now repeat step 3 and 4, 5. 5 means what? In Hindi, that is jab tak. Till. Okay. This will be 5. Okay. Means while I less than equal to. I write less than equal to. Means I less than equal to. Then only it will print hello 5 times. Okay. So equal to. Less than or equal to. Means that will be 4 and 5. Okay. 1, 2, 3, 4. If I am writing here, I am writing this using this symbol, then it also takes the 5. Okay, so I less than equal to 5. Then what? It will step 3 print hello. Print hello. Then step 4, that is set I equal to I plus 1. Okay, I plus 1. Then step 5 and okay, which means that step 2 repeat the step 3, this one and this 4 till I less than equal to 5. So the first one I. Okay, so I, now what we have initialized here? I equal to 1. I1. When I1, then the second step while I less than equal to 5. So what is the value of I here? The value of I is here. This is your 1. 1 less than equal to 5. This is the correct. So it will print. I am writing this side. Then this is print. This will print hello. First thing. Then print hello. Okay. Then step 4. Set I equal to I plus 1. I plus 1 means the value of I is 1 here. Now I equal to I plus 1. I plus 1 means 1 plus 1 equal to here 2. Now what is the value of I? Value of I is your 2. Okay. So in programming, this is your assignment operator. In programming, this is your assignment operator. Your 2 will be assigned to your I. Okay. So what happens here? Now the value of I is your 2. Now see here, 2 less than equal to 5, correct. Okay. Then it will again print hello. If it is correct, then again print hello. Then next then it will print hello. Again I equal to I plus 1. Now 3 plus 1 equal to your 4. Okay, so this is 4. Now the value of I is your 4. 4 less than equal to 4 less than equal to 5. Okay, 4 less than equal to 5. Yes, correct. Then it will print hello. Again. So 4 times 1, 2, 3, 4. Okay. But if I am not putting this equal to symbol, then it will stop here. Means it will print hello only for 4 times. Okay. So for that reason, I am writing here equal to, less than equal to. So that this is the value of I is now 4. So here this will be your 4 plus 1. 4 plus 1, that is your what? 4 plus 1, that is your 5. Okay, 4 plus 1 equal to 5. So here now the value 5. Now the value is 5. I equal to 5. And the thing is here, see, 5. 5 less than equal to 5. 5 is not less than 5, but it is equal to 5. So this is correct. Okay. So for that reason it will print again hello. Okay. So 5 times. Then I equal to I plus 1. Now the value of I is what? That is your 5. So 5 plus 1 what? 5 plus 1 is equal to your 6. Okay. So 5 plus 1 is equal to 6. Now 6. I am writing here 6. 6. 6 less than equal to 5? No. 6 neither less than equal to 5 nor less than equal to not equal to 5. Okay, 6. So the condition failed. It will not print hello again. So it going out from the loop. Okay. So here the loop started here. So it will end at this point. Okay. And is just in this point. If it's satisfied, then it will go to this point, plus it will go to this point. And again go back to this point. Okay. But it's not satisfied because of the reason it will not repeat the third step and fourth step. It goes out from the loop and it comes to this position. Okay. And likewise in your decision making also, if the condition is satisfied, then only it print. If it's not satisfied, then it comes out from the conditional statement. Okay, and the next statement which is present there, that will be print. So this is the basics about your problem solving methodologies algorithm. Next we will study about the flowchart. Okay.